Good afternoon, everyone. My name is Rick Drucker, and I'm the Business Development Specialist for Lesman Instruments Industrial Hygiene and Safety product lines. I'd like to thank all of you for joining us for today's webinar on the topic of Know What's in the Air, Detecting and Identifying Unknown Gases. Today's industrial hygienists and EHS professionals constantly rely on their gas detection equipment for accurate analysis and reliable detection of harmful gases in the environment. In addition, the challenge of detecting unknown gases and chemicals in the workplace, confined spaces, laboratories, etc., to protect workers, guests, and communities must also be addressed to assess if there is an additional risk to manage. Today's presentation will discuss intermittent odor and chemical exposure, how to assess chemical toxins in confined spaces, measuring multiple gases simultaneously, using NIST and EPA reference library of over 5,000 gases to identify the unknowns, and an opportunity at the end to answer any of your questions. Our speaker today is Jim Cornish of Gasmet Technologies. Jim has been working in the field of environmental instrumentation for more than 20 years. He joined Gasmet Technologies in 2008 to provide application, instrumentation, and technical support. He has extensive hands-on experience with many field analytical measurement technologies, including chromatography and optical measurement. Jim received his Bachelor in Science in Applied Chemistry from Deakin University, all the way in Victoria, Australia, and is actively involved in the AIHCE Real-Time Chemical Detection System, PDC. I'd like to thank Jim for sharing his time and sharing his expertise with our customers today. And on a final note, before I hand it over, we've had to mute all of your microphones, but we do encourage questions, so if you can please type them in the GoToWeb toolbar. If we can, we'll try to weave them in, otherwise we'll cover them at the end in a question and answer section. With that, I'd like to welcome Jim and turn the floor over to him.
Well, thank you very much, Rick, and all the team there at Lesman Instruments for coordinating today's webinar. And a big thanks to all the attendees for allocating time in your busy schedules to attend today's webinar. So what we're attempting to achieve today is give you an overall focus on FTIR, its dual functionality, briefly discuss the theory, how it works, how it operates, the applications. We'll pick some diversity in applications and look at that, how our customers are using FTIR technology to solve their air quality issues. And then we'll also look into the pricing aspect of the validation there and to wrap it up with your questions, etc. So that's the objective today. Let's get ourselves started. A quick introduction of Gasmet. Gasmet Technology is a Finnish company based in Helsinki, Finland, and it was in the early 90s that they came to fruition, and it was essentially their mission, or their whole focus has been to take the technology of FTIR, which was locked in laboratory really only capabilities through the 70s and 80s, and bring it into a field measurement. So that's what we've done, and over 6,000 systems have been delivered since that inception. You see the diversity of some of the customer base, from the military to academia, petrochemical, semiconductor, healthcare, universities, and all the way through there to Starbucks. So you can see the complete diversity in applications and users that we get involved in helping solve their air quality issues. Probably our key in FTIR, we're certainly not the only manufacturer of FTIR gas analyzers, but our key has been to make portable units. And on that right-hand side, you see how that has evolved since 2008. The Minneapolis, the American Industrial Hygiene Conference there in 2008 was the first release of the first model, first generation, the DX4030. And now we've evolved it into the third generation. We'll talk about the GT5000 Terra instrument as well. So quick overview on us. And so we have not just one, we're going to talk a lot about the GT5000 in particular, but we do get involved in combustion and process applications and ambient air. So we don't have to force fit analyzers. We can look at the application and then make the recommendation on what system would best fit the application. There is really two, it's what we call a dual functionality of FTIR. There is really two areas of applicability. And the first area is what we call quantify the known. So on the left-hand side there, we see applications, and they can be certainly the origins of Gasmet, and still today very strong in the emissions monitoring world, heavily regulated. The EPA is licensing the emissions from various plants, and so this tool can be used very much. It's a very strong tool because you're doing essentially all the gases that are being emitted are measurable. But then it can offspring into occupational health and safety. We do also a lot in climate change, quality control, and research areas. Now, what does that really mean? It means that on the right-hand side, we have a master component list of over 400, approximately 450 gases that can be measured. They can't all be measured simultaneously, but depending on the software package, you can measure 25 or 50, up to 50 as well. So you can be simultaneously measuring 50 gases from a master library of over 450. So that's hence the diversity. In that first slide we showed, whether you're in a petrochemical plant, whether you're in a hospital, whether you're in a research facility, those list of gases will vary. They will be unique to your situation. And essentially your mission then in the safety world generally is to say, hey, we would make sure that the employees workplace is safe, there's no toxic gases of any concern and that. And so that's referred to as quantifying the known. You know what you're looking for, and so this tool is very powerful in helping you accurately quantify these gases at very low levels, etc. The second part of it is where we unleash more power, and it has the ability to identify the unknown. So this is where, yes, smells, odors, you're reacting to perhaps a worker's complaint, there's concern on the workplace that there's a smell and there's an odor. Where's it coming from? So now we have a tool that we can take to the workplace, to the incident site, etc. And in combination as well with the NIST library of over 5,000 gases, we can go there, identify the unknown gas. We can then, from that, assess the situation, put in the controls that identify where the source of the gas is coming from, and very quickly be able to resolve the air quality issues in the workplace. So that's the two areas. So emergency responders particularly, this is a big area of interest for them because they've got a go-to tool that can assess over 5,000 gases with one instrument on that. So we're going to break that all apart here in these next little slides, help you explain how this is all possible with the FTIR technology. Very briefly, this is the overview. It's only the one tech slide I'm going to present, but infrared, number one there, infrared spectroscopy has been around. 1800s, B.B. and Lambert basically discovered that all asymmetric molecules, asymmetric just means they have two different atoms. We're showing the water molecule there. If they're exposed to light, the mid-infrared light in particular, which is the x-axis, about 4,200 to 900 wave numbers, then they all absorb with a unique fingerprint. So just like you and I, no two molecules have the same fingerprint. And the y-axis then means if you measure the absorption of the gas, it's directly proportional to the gas concentration. So the big highlight there, just above 2, is there's only approximately 14 gases in the world that cannot be measured. So the rest can. Those 14 gases we show there are the monatomic and diatomic homonuclear molecules, the likes of hydrogen, oxygen, nitrogen, and then the neon, argon, krypton type gases. And there's really only one outlier, the hydrogen sulfide molecule, H2S, is asymmetric, but it is a very, very weak infrared absorber, so it's not measurable, not feasible. So with those 14 off the table, the rest is that we can measure all the inorganics and organics that are volatile. So that gives you a very powerful analytical technique. The FT, which is the central part, is actually been the forefather was Dr. Albert Michelson, a US physicist, that was trying to find a way to calibrate the speed of light. And so he basically created what's called this interferometer. We take the light source, the infrared, And he placed what's called a beam splitter, which is just a piece of glass that's coated. And then he put 2 mirrors in his system, one that's fixed and one that moves. So the light is coming in and 50% is going through and bouncing back, 50% is going to the second mirror and also bouncing back. But this, of course, is moving in time, and it creates what? Guess what? An interference pattern. And that's referred to as an interferogram. And so that is collected. That's the physics that's happening at 10 times a second. And then the gentleman that actually gets his name on the front end of the technology here is Jean Fourier, the French mathematician. He says, haha, I can help you here. You've got frequency versus time. I can help you transform that to frequency, the x-axis, versus intensity, the y-axis. So that is, mathematics happens in the second part. So we've got physics and math. So we get simultaneously all the light of the mid-infrared. So the big bonus or feature of the FTIR technology is that you must have this internal laser. It's a helium neon laser that works in tandem with the infrared light here. And it basically locks the x-axis. It gives us a reference point. So with that reference point on your x-axis, think of it as an internal calibration. So the instrument does not need to be recalibrated. So the only thing we need to do is what we recommend is a daily zero of the instrument, and that counters for old age in the optics, etc., by zeroing the instrument. So rather than having to have 450 calibration gases, no, we don't need to. We just zero the instrument, and that's another huge advantage of the technology. So that turns it into a simple operating instrument. So here's the interferometer, nothing the user needs to do. The mirror is moving small distances back and forth, and the gas is coming in. It's brought in by a sample pump in and out of the gas cell. So you've got the interferometer at one end, you've got your detector at the other end, but they never touch the gas. It's going in and out of this. So keeping this gas cell dry and clean, we have a very low operation maintenance instrument. So that's a quick overview. So then in terms of turning it into technology that's useful for people in the field, and over the years, Gasmet has calibrated over 450 gases. So that's the master component library. And from those, then you have the ability to draw on a gas, put it into your application library, and measure it over a specific range. So if I picked on hydrogen fluoride, here it is. So it's calibrated over the range of 0 to 50 ppm, and you'll be able to directly measure that. And as mentioned, we can also draw in the NIST library for a qualitative analysis, which we'll show you momentarily. Sensitivity is obviously very important in technology, and so with the use of a path length of 5 meters or 16.5 feet with the instrument, we can get down into the sub ppm and ppb level. This is molecule or gas molecule dependent, the epsilon constant in the equation. So here we're saying there's 25 gases we're listing. This is a common TIC application library. And in brackets, we're saying the aquilin gas has a detectability of 60 parts per billion, 0.06 ppm, ethylene oxide 0.05, formaldehyde 0.04, etc. If we were to write number 26, hydrogen sulfide, it would literally be greater than 100 ppm, and you can see how much of an outlier it is. Here's methyl mercaptan, here's carbon disulfide, so it's not the sulfur, etc. It is purely that molecule. So these are in line with the PALs, the occupational health exposure limits, etc. So it's an excellent tool to be able to go into the workplace and assess worker exposure to levels of various solvents and toxic gases, etc. So operating, so here we now sort of talk about the model, the latest model, the GT5000 Terra. So how does one operate the instrument? Well, the first thing you'll notice that there is no display on the instrument. You're using it in conjunction with a tablet. We supply a ruggedized Windows-based tablet that talks to the GT5000, and it can talk via several methods. We can have a cable, we can have Bluetooth, we can have Wi-Fi, or even Ethernet, etc. So whether you want to be close to the instrument or you want to be remote, that's quite possible. So this is being used in conjunction. So it's sending the information back here for your display. So operating the instrument itself is very quick to get up and going. Basically, you choose between DC lithium-ion battery or an AC powered pack. You get 3 hours from the lithium-ion rechargeable battery. Warm-up time is relatively quick, and it's really a delta T between the difference of where you've got the instrument stored and where you're going to be using it. Obviously, the bigger the delta T, but typically 5 to 15 minutes, you've got the instrument thermally stable. And then the third step is to do a zero of the instruments. We typically recommend nitrogen, UHP grade nitrogen, connect it up to the instrument to the zero gas port, push the zero button, and the instrument zeroes itself. We do a quality control check, and assuming that's all fine, then you're ready to go. There's no other cal gases or any other consumables required, etc. So yes, it takes just a couple of minutes to get the instrument set up. Your sample line here is connected to the sample in, and behind that is a internal diaphragm pump there, Teflon diaphragm pump. And well, this is showing a relatively short distance here. You can certainly have that extended, and we have people using up to several hundred feet of line in specialized applications for that. So then most of the operation of the instrument is coming through the software. Way back in 1995, Gasmet patented, brought to the market, Calibration software, and it's now in its 14th edition. And so it's the interface that here this lady's looking at on the tablet. And what that's going to show her is your application library. So you're going to get your gases up to 25 or 50, as I said, depending on the software version. Your gas concentrations, typically in ppm volume, a bar graph, and representing the measurement range. And so that's just the calibration range. Remember, it's not to do with the detection level, though typically the more toxic the gas, the lower the measurement range. And another big bonus of importantly is this residual column, and it's a way it directly shows us or tells us of the success of the analysis. And we use just a color code of green being good, being okay, and yellow and red being an alert. There's something going on, there's some other gases. I'm going to show you that momentarily. So the readings can be updated like as quickly as every 5 seconds, 20 seconds, or 60. The actual interferometer is working at 10 hertz. So every 10 times a second, you're getting a reading, and then we can collect 50 readings and then update simultaneously all that. So we generally use something like 5 seconds if we're looking for a leak. If we're looking for low detectability, best detectability, we'll use something like the 60-second measurement range, but that's user selectable. You're going to get alarms, not only for that residual, but you'll get concentration alarms, audio and visually can be set up by the user, etc. The results are available as a text file. So every time you take a reading, you're getting all the gas concentrations in a text file, and then that's openable in Excel, so you can do further processing, etc., graphing, and putting all your results into reports, etc., in a timely way there. So we talk about a lot about how if you've set up a list of gases and you know exactly what you're looking for, but of course, when you're going in to solve an air quality issue, often you don't have all the information, odors and smells, where are they coming from? So how does that all work? How do we use the power of the FTIR? Well, we have what's called a Hazmat application, where we use these 10 gases. We use these 10 gases to actually directly read them, should they be there, but the chances still are that that's quite low, given how many gases are used out there in the various labs, in various facilities, storage, etc., where you've got thousands of difference, but they can be our alerts. So what do I mean by that is that with setting up these 10 gases, we can then know the presence of over 5,000 gases. So what I'd like to do now is I'm going to jump out of here, and we're going to open the KKM software. So you should be seeing now on the screen the KKM software, and it's also showing what we call it's a clean air spectrum. So we talked in the theory about how our x-axis is the wave numbers, 4,200 to about 900, and the y-axis is absorption. So here in this clean air, where you're thinking, well, that doesn't look too clean to me, but yes, in fact, that is water vapor, that's carbon dioxide, and that is water vapor. So if I lower this down, so the software then is taking that and converting that into readings. So in fact, in that sample, we have 0.33 volume percent, 3,300 ppm of water vapor, 400 ppm of CO2, and 2 ppm of methane, which is correct. Globally, methane is about known to be an average about 1.9 ppm around the Earth. And then we have these other parameters all showing 0, clean ambient air. We don't expect to see them in that. So that's simply how the software is taking the measured spectrum and then converting it to readings. But what if now we load another spectrum? All right, we'll call this 3 solvents. And so we'll go over here. So now what we've just done is loaded a different spectrum. We have our water vapor, as we said before. We have our carbon dioxide and water over here. But now we have other stuff. We have other stuff in the sample down here. And so now when it goes to interpret that other stuff, it knows that there are 10 gases in the world. It knows their signatures very accurately. And what it's telling us is that, hey, through this yellow and red, there's an unsuccessful match, which is defined then as there's something else in this sample that's not in our application library. So the next step for the user then is using this identify button. By pushing this identify, it's taking the measured spectrum and then it's going through, and there's 2 databases we have available. Is the Gasmet library of over 450, where it can accurately identify and quantify, and then it can loop over to the NIST library of over 5,000 gases. And momentarily, what we're going to see here is the fit. So it's doing a statistical fit to show us what's in the sample. So here it's finalizing results and saying, it's saying to us in this sample, I find the presence of acetone with a 99% hit quality, certainly, and concentration, isopropyl alcohol, 98%, and ethanol. So now if I add these components to the library, now I go back over to my results. So now that I've got these 10 gases plus these 3 components that it's found, it's showing now a green residual, which is telling me a successful analysis. So whether it's 1, 2, 3 or more, you've now got we know what we're dealing with. Now we can go ahead and we've assessed the situation. Where could that be coming from? How do we deal it? What controls do we need to put in place, etc. So that's kind of what's happening in the software and its power. We made the measurement. It then got compared or identified through the database. We've added the gases to our application library. Everything's green, so we're ready to go to the next level. If we need to walk around and quantify, it can be directly measuring now the acetone, ethanol, and isopropanol. If we need to figure out further where it's coming from, etc. All right. So with that said, all right, So that was kind of how this all works. So we use that to go ahead to be able to identify based on that. And just as an FYI, if you're interested, a trip to CVS or Walmart, etc., that's what we just measured. These 3 components were put together. So ethanol, isopropyl alcohol, rubbing alcohol, and nail polish has acetone in it, etc. So that's what the actual direct measurement was of. All right, so application-wise, yeah, very diverse. So we have VOCs, whether it's formaldehydes, the benzenes of the world, etc. A tool to be able to go into the workforce there and whatever, capacity of refinery, chemical processing, etc. Contaminated sites, Hazmat, as you can imagine, very powerful tool for the first responders. Medical, whether it's gas testing in the healthcare facilities, remediation sites, fumigants, semiconductors, etc., etc. So yeah, it's certainly diverse because of the various. So just highlighting here very quickly some applications. And so here, this was a pipeline company, and they needed to assess when there's a leak. They use right-of-ways, and it's not necessarily they need to source what is leaking. And so we did. This was a perfect tool for them, and we did some live demos to prove it. They basically had the ability to provide samples there. They have ethylene and propene and butene and all sorts of fun things, and we needed to just to prove to them that we can separate that out and tell them exactly, so they know what's in their pipes and they know what's not in their pipes, so then they can figure out whose actual pipeline that's coming from in a leak situation. And that was just a quote that the user, one of the users, shared with us. The analyzer had already paid for itself after 5 months of operation because of its accuracy in identifying exactly what gases were being measured. Here's another. This now takes you to university. This is Duke University. It was a presentation at the American Industrial Hygiene Conference. It was 2020, just in the first year of COVID there. And what they were looking at is formaldehyde exposures in the pathology labs. And what they wanted to do was see what steps in the workplace they could mitigate this out. That obviously the pathologist and the assistants in their transfer handling of the sample. And so they did they went in, and so you see the DX4040, the earlier model here, being used to monitor that. And so at certain critical times, the formaldehyde that they were measuring was spiking, basically. So what they then said, well, how can we change these processes, etc., to lower those levels, etc. So that was their way of going and putting in better controls, etc., ventilation, etc. So this was Stephanie Keller's presentation that was provided in 2020. So accurately measuring low levels of formaldehyde is one of the applications, etc. Very much so in the healthcare world, we do a lot with WAGs, waste anesthetic gases, in the surgical suites. A number of these days, originally it was very much nitrous oxide, but they used desflurane and SIVO, a lot of isoflurane used with veterinary clinics, etc. But the exposure, the patient is actually injected with quite a large volume or concentration in the anesthetic process. But they have to be sure that once they're ventilated that at the end of the surgical procedure, that the concentration of the anesthetic gases is low, so the staff in the operating room, the staff in the recovery room are not being exposed to excess levels, etc. On that. So then the folks at Banner Health down in Phoenix, Arizona, they had used their instrument quite a lot, and we have a presentation up, or certainly a blog up on the Gasmet website that deals with the different applications. And they not only with the ORs, then they started diversifying into some of their other areas in the hospital. So they found quite a few different applications for their Gasmet system. Another diverse area is in this case, in the production area, where they basically were using it to find an accurate way to allow the workers to remove their PPE. Obviously to be able to increase their productivity by taking the PPE off, but it was to do with carbon disulfide, and it was being used in part of the production process. And then after time, of course, with the controls in place, the concentration would drop down to acceptable, lower than quite a bit lower than PEL concentrations, and so that gave the ability for the workers to take off their PPE and then increase more their mobility and productivity, etc., on the production floor. So no, that was just, again, they could rely on the accurate interference free readings that they were getting from the Gasmet technology. In terms of operation and maintenance, it has a low cost of ownership, as we call it. We're dealing with the zero gas, being a nitrogen, 99.99 UHP grade, but the consumption is usually about 10 liters. We usually run at 2 liters a minute for about 5 minutes, and that's so depending on the usage of the equipment, and of course this is readily accessible from your local supplier, Lesman, and folks like that. They can supply it in different sizes, etc., for you. So it's a relatively easy accessible, storability, etc., and relatively low cost. And the only other consumable with the technology is a particulate filter. So the only removals we're doing is we're doing nothing with the gases, but we're removing particulates 2 micron and larger, so that they don't sit on the optical, on the mirrors, etc., that are inside the instrument. And so periodically, it really depends on the application. If you're in clean rooms inside, it's not nearly as frequent as you would be changing if you're in an outdoor environment, etc. But that particulate filter. But other than that, keeping it dry and clean is the most important thing. No requirement to send the instrument back for annual service. That's in red because sure, hygienists or safety people are so familiar or used to once a year. Yeah, it's that time of year we need to send it back to the factory for recalibration. But as we always say, we're happy to take your money, but there's nothing that we can't do that you're not seeing every time you do a zero. You see the optical health of the analyzer. And yes, there's quality controls to make sure there's been no fouling, etc., that you go through. But if it's meeting that, there's nothing that needs to be done for the instrument. So again, on average, we're finding now we're not seeing the instruments back, certainly under 5 years, 5 to 10 for people looking after their instruments. So it has that low cost of ownership, etc. on that. Validation of the technology. Certainly Gasmet did not invent FTIR. It's been around since really the fast Fourier transformation came out in the late 60s there, in the 60s. But as I said, mostly limited to laboratory applications only. So it's a recognized test method, NIST test method 3800. It's a measurement of organic and inorganic gases by extractive FTIR. US EPA and the ASTM group have standard methods for FTIR on that. So Gasmet has certainly gone into a lot of testing over the years. Prove it. It's the old, prove it to me that this is true and it's doing what it is. So third-party validation is certainly continuous with various third-party organizations, etc. Many publications over the years now in the industrial hygiene, emergency response, and the military area. The US military through their Edgewood research facility in Maryland back about 2010. They said, oh, this is all very nice, but we really need to prove this ourselves. So they took an analyzer, took it for about 3 months into their labs and went about testing it with various ticks, etc. They published about a 42-page unclassified publication, and their conclusions, it was the model 4015. The instrument was accurate when measuring the concentrations of each gas, and it showed excellent sensitivity and selectivity for each of the gases, etc. So we're happy to share that that document. It's to say it's unclassified, but it just gave the assurances that our publication to specifications were being met, etc. If you want to get much deeper into the spectroscopy, the American Industrial Hygiene, their real-time detection book, Dr. Smith and colleagues had published that. It goes into all the things you probably don't want to know about FTIR, but the deep derivations, etc. So lots of resources there available to go deep into the technology. Pricing wise, so what we've done right from the initial release of the DX4030 way back 2008, we have on purpose respectfully sort of broken the price into two areas, and what I labeled them and sort of explained early on in slide 2 or 3, that if you want to quantify the known, meaning you need a device where you've got known gases to take it out to the workplace and measure those routinely, and that can be up to 25 gases, can be proposed. Then on that left-hand side, in combination with the tablet, you see the Windows tablet there, a battery, the sampling wand, etc. And that's your sort of your price. Is around about the 54,000. If you need a backpack and a transport case and a few things others, they're optional accessories. So that's kind of get you what you need. And we have a lot of those. The climate change people, they have just a set list of gases. We have other areas in research in that's all they need, just an accurate way of quantifying a series of gases. We then, on that right-hand side, say now if you need the full power to identify unknowns, access the 450 gas library, all those components, and the NIST library of over 5,000, then your pricing ends up in the 65 there, plus the NIST, etc., $70,000 and that. So where's the justification come? It certainly is for people that have these toxic gases, that they need to make sure that their production and their workplace is kept from having to shut down because of smells and odors and problems they're facing. We understand that certainly the ability to have a tool that can come and quickly assess the situation, mitigate without making the 11 o'clock news because of issues, being able to keep the peace of mind of the workers that you've got their back, you've got a tool that's making sure that they're in a clean environment, not being exposed to carcinogenic gases, etc. So yes, it's not an inexpensive capital cost for sure. Thinking of this over 10 plus years, then the cost comes down to much less on a yearly basis when you amortize it over those sorts of areas. I know it gets a lot of sticker shock. People see that and fall off their chair and have to pull themselves back up. But the value they're getting is certainly the ability to be able to confidently resolve air quality issues in their workplace. Rounding it out, this is the last slide here. Here we're just summarizing what's the FTIR technology, what's it driving, and how is it helping you solve these air quality issues. You've got one tool essentially that can provide a fast response from taking it out of the box, so to speak, to getting it started, and then directly measuring if your quantification, or using the Hazmat library to identify unknowns. Then it's very a quick direct reading. The 5,000. Ease of use, that CalcMet has said is its 14th version, and we're continuing to improve through customer feedback. So much is driven by customers saying, well, what is it? What if we could do this? Or it'd be nice if we could do this. It's Gasmet's CalcMet is our software, so it goes directly back to our software engineers who can evaluate and look at these improvements in the future versions. Validation of the results. As a chemist myself, I love this because the spectra, which is tamper-proof, once it's recorded, meta-tagged, it can't be changed, can always be reanalyzed. A second set of eyes can look at it, make sure that it's what it is. And so it's a very powerful, you're not just reading a number from a display on your instrument and hoping that is correct. You have a way to trace it all the way back to prove it's correct, etc. The low cost of ownership we've talked about there. We're not no calibration gases, no carrier gases. So it has an inherently a low cost of ownership. We're just asking the user to be respectful of the gas cell. We want non-condensing sample. We don't want any hot, moist gas that could condense. We have ambient air analyzer. But if that's done correctly, then yes, we're not expecting to be doing maintenance on these instruments for years, 5+ years at least from seeing them out the door. And the last one I'm just saying is sidestepping redundancy. When the 4030 was first released in 2008, we had a component library of 170 gases, and today that's 450 gases, and that continues to increase, and all our users have access to that at no charge. Currently anyway, no charge. And so as new gases, mankind with freons and other gases come onto the marketplace, we have the ability to have them calibrated and then add them to the application library or to the master component library, etc. So with that said, yes, that is sort of an overview. Happy now to take your questions and feedback. Certainly Rick is there, very strong support locally there in the Midwest through the Lesman Instrument Group. So happy to engage in the discussions, but also to thank you for your time this afternoon.
Thank you, Jim. That was great. We do have some questions, and some of them I know you've answered since they've been asked. For example, somebody just talking about how often does it need to be calibrated, in which case you mentioned doing a zero gas, is the only calibration it needs, and that should be done. If you could just confirm how often they should do that.
Yeah, the recommended frequency is each time. It's not compulsory. I answer that cheek and tongue to people who ask it, how important is the data? Because if it's really important data, yes, you want to do that. The instrument doesn't age radically from last time it was used. The point is, you don't, if it was you and you absolutely know it was you, and you put it with kid gloves back in the box and you know what's there, then you're not expecting any changes. But it's a way to make sure that the instrument was not fouled, it wasn't in any way dropped or banged. So that's the reason we want and sort of recommend you've got full assurance. But we do have first responders and people like that will actually do it after they come back, and they don't have that time factor, that 5 minutes. It's all about being there. When you turn it on and make your measurements, ambient air through the water vapor, carbon dioxide, methane, and nitrous oxide are actually known values. So we can use them as calibration points free of charge to validate the instrument. But in general, the zeroing at the start is the preferred method.
Awesome. We also just got the question, what's the normal lifespan of the GT5000?
Yeah, we don't know its lifespan, but we do know from history we have instruments being used over 20 years. And we've done a blog that's up on the Gasmet website where a customer was retiring their instrument after 20 years. Gasmet, like we are all instrument manufacturers, so when and there's several reasons. It's not the only reason, but if you look at the picture of, let's say, this one, the one that's going to go more obsolete quicker than the other is your interface. So the nice thing is, if we're running it currently on the Windows platform, so we rely on Microsoft to keep producing Windows, but there's a fair chance that this form factor is going to change in the next 10 years, whatever, and it doesn't concern anything to do with the instrument. So that's making sure that we don't run into redundancy. If you have your display here, then the manufacturer decides to stop making that display, that you become crippled by that. So that is, part A is just the technology side of things, and part B, I mean, we've been supporting and support all our instruments for 10 years after they are the end of life, as we call it. So an instrument like this, we expect it certainly to be running into 2030s when Gasmet decides to move on to the next generation. Then there's nothing I can speak about that directly, but that's the sort of time frame you can expect.
Appreciate it. We've had one asker that was concerned about overload, that they've heard about overload, that what can users do to prevent overloading?
You've lost me a little bit on the word overload. And maybe I'm not going to pinpoint, but let's jump there. I mean, training is important. We want to do training, and it's an evolutionary process. To get people to using the instrument is fairly straightforward, and obviously the importance of the calcment, getting them training to be confident, but if they're going to be doing lots of changing of application libraries on that. So that's very important in the supply and support. Overload, I don't quite understand if they mean overload on the gases on the computer. I don't know if they can elaborate on overload.
And they just did. I just got a second question that he mentioned overload and then parentheses contaminant on the sensor.
All right. Okay. Excellent question there. So let's quickly just go back up. All right. The two things. I'll jump back up to this one to explain it. So you can't get contaminant on the sensor. That's not possible because the gas is never touched. There is no sensor per se. So this is the gas cell we mentioned, and the gas sample is being pumped in and out of here at about 2 liters a minute. This interferometer butts up to what's called infrared transmittent windows. So the infrared light goes into the cell, it bounces using mirrors, gold-coated mirrors that are rhodium-coated for robustness. And then on the other end is also windows that go ultimately to the quantum detector. So you can't poison, you can't foul a sensor because it doesn't exist. That's number one. Number two is in the technology then, and it's an example here of saturation. So we work in the linear range of the mid-infrared. And if a gas does this, goes up that's telling us the concentration is too high. So what we have to do is dilute or pull back. But our normal measurement range in occupational health and safety is no. We're usually measuring gases at ppm and sub ppm. We're actively down here, so we don't run into it. But it's not unknown that a client might say, well, what's in this drum? It's unlabeled, and we need to help assess what's going on here. Use this to tell us, is it just water and we can just tip it over into the drain, or is it some sort of a solvent that must be treated safely? And they'll take the probe and then they'll open it up and put the probe right in there, and the next minute, this will come straight up to the top and out, which is telling us they've got a lot of something. It's there's a really high concentration. And all we're saying, all right, pull the probe out and let's dilute that, let ambient air dilute it, and sure enough, that'll come back on scale, and then you can measure it directly. So that's called saturation. It's having no effect on the operation of the instrument. It's just stopping us from being able to accurately quantify it. But again, repeating the point, whether any of these gases, they never touch the detector because there is no the sensor, I should say. There's no sensor in the technology.
Which is good. And also, first of all, the asker said that it was well explained, and thank you. So, I think it also answered the question, in terms of someone asking, can or should the cell be cleaned if it becomes contaminated? But if I'm understanding you correctly, that's not the case. It can't be.
So what we recommend, is we've talked about the front end, warming it up and then zeroing it and getting it going. So then we're measuring ambient air out there. So the shutdown procedure after you're finished is certainly to bring it back into a clean environment and run it 3 to 5 minutes. Let the pump just actively pull clean air in and out of the cell. And you can see the display. You'll see the readings should be nothing. You should be back at just ambient air gases and zeros, all right? And that's all you need. You've convinced yourself everything's fine, then you can shut it down, because we don't want to leave these corrosive gases. Although we make the mirrors have got all coated with nickel rhodium, so they can take aggressive gases, but you don't want to go on chance of leaving gases that's sitting there. They're not going to do anything good over the next time. So leaving it clean, then shutting it down. We'll even have people that will go to the trouble of putting nitrogen through it as well at the end. And in certain environments where you've got some pretty strong corrosives, that's not a bad idea. But generally, ambient air, clean ambient air is all you need to do.
Moving on to the next question then, we're being asked, how are new gas, when new gases are found, or are they added to the library, and would they have access?
Yeah, sure. That's the process of the gases. I mean, sorry, I got the wrong way. This list, and I only showed 350 on this list, but right today it's 450. Is that basically clients come to us, and then it goes back to Gasmet has a full calibration lab at the production facility. They assess it. Hey, I want to do trimethyl chicken wire. So is it too toxic to handle? Is number one. No, that's fine. We can access it. We need to access it in the pure form. And then they assess, depending on its uses, a user might have to buy it. And that can range from $500 to a couple of $1,000. It really depends on the uniqueness and the cost to access the gas. And then we end up basically emailing the user the references. So, and again, number 451, trimethyl chicken wire. So it's got a calibration range we've agreed on, 0 to 20, 0 to 200 ppm, whatever makes sense in the application, and they measure that. But part of Gasmet's condition is that's then shared, so all people have access to it. So anybody else that needs that, we can. So that is then shared. We don't have a direct way of doing it from a website yet. We just share the references to customers as they need them, etc. But it is a no cost to our customers, and that's just the way we think it's the fairest way. That any customers already sharing 450 that they didn't have to pay directly for. Of course, it's in the price, but that's the way we do that. And within the version of the software is kind of our only thing. Is if we change in the future, then sure, that might change. But currently, there is no charge for sharing those calibrations.
Which kind of ties into a question that I have about, so you've explained how, the two softwares, the Easy and the Expert, and by the Expert getting the additional gas library. From an application standpoint, what would make somebody, what applications would work well, I guess is how I'm reading this, for just having the CalcMet Easy versus the CalcMet Expert, and when do you see in what applications they really do need the Expert?
Yeah, so the premise is really that if we pull that back up, is that the application library so with Easy, there is no mechanism to add additional gases to the application. So they've got a defined application. And this happens, and the path to upgrade is quite easy as well. Obviously, the dollar figure is perhaps not as easy, but the path is, and it's just a key, just a hash key. So people, and I made one example, climate change, and people who have a defined application, we'll find that even in healthcare, people that just want it for WAGs, they say, hey, I don't need anything else, I just need to do these group of WAG gases. We'll have it in other kind of industrial settings where people in the production facility they only have a list of 10, 12 gases. And so that's all they set it up for. And it's just on a proviso that they can't change it in the future. And that's if they want to change it, and it's done through the software. So if I just pull this key out, so if I take this in a moment, and your attention to that. So this is where I can access the Expert, but right now I have a hash key in, and now by taking that out of my computer, I don't have access. So in the future, if I purchase the CalcMet Expert, which is a key, it's just a little hash key, I put it in, then I have access.
Awesome. So it's, again, and it would be part of a conversation that we would have about particular application, what they're trying to accomplish with it. It's always important with this technology to have a qualifying conversation and make sure that the cost of doing nothing usually is necessary to outweigh the cost of the equipment. There are, if you've got known gases, there's many gas detectors for those, if that's all you're looking for lower costs, but that will not be able to give you the unknowns. And what is the cost of not knowing those unknowns is a lot of the conversation that we should have.
Yeah.
I also, I was asked, will we have access to the slides? Absolutely. We will both send, we are recording this and will absolutely send everybody who has registered a link that they can go onto our site and see this presentation again. We were also asked if Lesman will have these to rent. Lesman no longer rents, we only sell, but there are companies out there that do rent them. Let me just see if I'm well explained. I believe I have gone through each of the questions asked. I hope if there's any that I missed, we'll show the, if you can go to the contact slides at the end of our presentation, just so that everybody can have that there to take down my information. And feel free to email me if you, one, have any question that wasn't answered, or two, you have an application specific question that you would like to talk about. Please just reach out to me. In addition, I always put out there that if anybody out there would like to know about other technologies we support, all of our webinars are posted both on our website at lesman.com and on our Lesman Instrument Company YouTube channel. So you can not only see this one, but there are many other very specific webinars that we've put out there. And we always ask our customers if there's any specific topic that you'd like us to cover in a webinar, please email me that subject as well. In that Lesman has lots of product and process specialists, so we can cover a pretty wide range of topics, and we're always happy to do so. Jim, I just want to thank you very much for the informative presentation that you've given us today, and just thank you for your time. And I also want to thank everybody else who has joined us today, and we do hope to hear from you in the future.
Thank you, Rick.
If there are no specific questions, I will I'll conclude the webinar so we can stay on schedule here for everybody. And I thank you all very much.